Module 4 continues with Part B, creating tutorial-based destination paths and modifying a requisition. This module will create 3 destination paths, each initiating notifications to the flowers group in some fashion and escalating to the def user after 5 minutes. The first destination path will access the on-call flowers member. The second will blast a notification to all members of the flowers group at the same time. The last destination path will contact each member of the flowers group in alphabetical order at 2-minute intervals. Begin by accessing the admin configuration page and click on Configure Notifications. Then click on Configure Destination Paths. Click on New Path. Enter the name On-Call Flowers. Edit the initial targets. Select the flowers role and click on Next Step. Select Java Email and set Auto Acknowledge to On. Click on Next Step. Click on Add Escalation. Select the def user and click on Next Step. Select Java Email and set Auto Acknowledge to On. Click on Next Step. Set the escalation delay to 5 minutes. Click on Finish. The On-Call Flowers destination path is in the drop-down. Click on New Path. Enter the name Group Flowers Blast. Edit the initial targets. Select the flowers group and click on Next Step. Keep the delay at 0 minutes. Click on Next Step. Select Java Email and set Auto Acknowledge to On. Click on Next Step. Click on Add Escalation. Select the def user and click on Next Step. Select Java Email and set Auto Acknowledge to On. Click on Next Step. Set the escalation delay to 5 minutes. Click on Finish. Click on New Path. Enter the name Group Flowers Stagger. Edit the initial targets. Select the flowers group and click on Next Step. Set the delay at 2 minutes. Click on Next Step. Select Java Email and set Auto Acknowledge to On. Click on Next Step. Click on Add Escalation. Select the def user and click on Next Step. Select the Java Email and set Auto Notification to On. Click on Next Step. Set the escalation delay to 5 minutes. Click to finish. View OpenNMS_home/etsy/destinationpaths.xml. Each of the new destination paths is in the file. The destination path Group Flowers Blast has an interval of 0 minutes, meaning that all members of the flowers group will get an email at the same time. The destination path Group Flowers Stagger has an interval of 2 minutes, meaning that each member of that group will receive an email at 2-minute intervals in alphabetical order. Finally, the destination path On-Call Flowers will send an email according to whatever the schedule is in the flowers role. Returning to the GUI, each of the destination paths is in the drop-down. Select the Group Flowers Blast from the drop-down and click on Test. View each flower group member's email. In the blast, all flowers group members are sent an email at the same time. Note the time at 16:53. This should be the time across each user's email. Return to the GUI and select Group Flowers Stagger destination path. Run the test. One would expect that this should send test message emails to each member of the flowers group at 2-minute intervals, alphabetically ordered. Unfortunately, in test mode, this does not work. In test mode, the stagger destination path works as the blast destination path. Just keep this in mind as you run your tests. Return to the GUI and check out the on-call schedule by selecting the selected drop-down and clicking on On-Call Schedule. Note that Lily is currently on call. Return to the destination path using the back arrow and select the On-Call Flowers destination path. Click on Test. Lily is the only member of the Flowers group to receive a third test message. This concludes the tutorial on developing destination paths. These tutorial destination paths will be used in the tutorial on developing notifications. Notifications are initially set to off. As pointed out in the original OpenNMS 101 Module 4 video, it is a good idea to turn notifications off when restarting OpenNMS. This can help avoid a blast of notifications that might happen on restart for various reasons. There are several default notifications shipped with OpenNMS. Some of these are turned off so that even if notifications are turned on at the top level, events associated with these notifications will not generate notifications. If this is confusing, it will be made clear in a moment. Provisioning at requisition, to be defined briefly, of the OpenNMS host has changed since the original playlist was released. That will be accommodated. One of the pre-installed notifications deals with a loss of service. That will be demonstrated. Tutorial notifications will be developed based on the events and destination paths developed in this module. Auto-acknowledgement will be demonstrated. And finally, this module will cover using external commands to provide notifications. To turn OpenNMS notifications on, go to the Administrative Config page. Midway down the left-hand column, there is a Notification Status radio button. Turn it on and click on the Update button. To view the current notifications, click on Configure Notifications and then on Configure Event Notifications. This is the delivered set of notifications. There are 9 notifications installed with OpenNMS. High threshold rearmed, low threshold, and low threshold rearms are notifications that are initially switched off. Interface deleted, interface down, node added, node down, and node lost service are initially switched on. Rather than create a new virtual machine or use the VM host to demonstrate the interface deleted or down, or the node added or down, it will be much easier to demonstrate the notification for node lost service. To view notifications, from the status bar, select Notifications. Click on All Outstanding Notices. At this point, this is an empty list. Click on the info bar element and select Nodes. As there is only one node in the system, the selection will bring up that node's front page. The upper left area is a list of services that OpenNMS is aware of on the local host. To demonstrate the node lost service event requires adding a new service to the list of monitored services on the local host. This is because killing ICMP on 127.0.0.1 might prove problematic, and killing OpenNMS-JVM would kill OpenNMS. There are other services running on localhost. We need to monitor those services to test the lost service notification. But first, what is provisioning? Provisioning is the process of adding nodes. One method of provisioning is directed discovery. Directed discovery adds nodes using a requisition. The requisition defines the policies, service detectors, and scan interval of associated nodes. The requisition used to define the policies, service detectors, and scan interval of localhost is self-monitor. Self-Monitor has a limited set of service detectors. SSH and SMTP will be added. SSH is the secure shell, and SMTP is the mail server, snail, installed in Module 2. The demonstration follows. Jump to Admin Configuration. Click on Managing Provisioning Requisitions. Click on the pencil icon on the Self-Monitor line. This produces a list of nodes in the requisition. Click on the Edit Definition button above the node listing. A list of detectors associated with the Self-Monitor requisition is presented. Scroll down to get a list of services the Self-Monitor requisition tries to pick up. Note that there is a detector for SNMP, whatever that is, but SNMP was not one of the services listed on the node's front page. That will be covered in another module. Click on the Add Detector button at the top right. Any name can be given to the detector, but it is best to be concise. Call the first detector SSH. For the class, type SSH, and a detector class entry is produced. Click on Save. The SSH detector is listed at the bottom of the detectors list. Click on Add Detector button at the top right. Any name can be given to the detector, but it is best to be concise. Call this detector SMTP. For the class, type SMTP, and the detector class entry is produced. Click on Save. The SMTP detector is listed at the bottom of the detector list. Click on the blue Save button at the top of the screen. The requisition has been saved. Then click on Return. At this point, click on the Synchronize button, which in this case is equivalent to rescanning the node with the updated requisition, which now includes the two added services, SSH and SMTP. Select Scan All Nodes. There are other options, and Synchronize, Scan Added Nodes Only, will only look at new nodes added to the requisition. No scanning just postpones the scanning until its scheduled time. Click on the Return button. At this point, if there were hundreds of nodes in the requisition, the rescan would be running. As it is, there is only one node, and the rescan is probably already completed. Click on the info bar element and select Nodes. The node front page indicates that both SMTP and SSH services are up. At this point, notifications have been turned on. Notifications are triggered by events. There is an event, Node Lost Service, which triggers when OpenNMS can no longer detect a monitored service on a node, and OpenNMS has been configured through the modification of the Self-Monitor requisition to monitor the SSH and SMTP services on the local host. The plan is to stop the SSH service on localhost and look for notifications. Up next, Module 4 continues with Part C, First Notification and Notification Configuration.